Jupiter is the largest planet in the solar system. More than 1,300 Earths could fit inside this gas giant. It's also 2.5 times more massive than all the other planets of the solar system combined. But if you think this is mind-boggling, I've got some great news for you. Very recently, a team of astronomers has discovered a much bigger planet with the help of the Subaru telescope and the NASA Hubble Space Telescope. It's a Jupiter-like protoplanet orbiting a very young star called AB Aurigae. The star is probably still forming and is no more than 5 million years old. For comparison, our Sun is 4.6 billion years old. The young star is located around 531 light-years away from Earth in the constellation of Auriga. The star is shrouded in a thick, quickly moving layer of gas and dust. This disk feeds the growth of the star. Later, what is left of this disk will come together to form the elements of the planetary system: planets, dwarf planets, comets, asteroids, you name it. But back to the newly discovered planet. It's a gas giant whose mass equals that of 9 Jupiters. Can you imagine this colossus? It takes the planet, named AB Aurigae B, almost 588 Earth years to complete just one journey around its parent star. Maybe because it's 93.9 AU, astronomical units, away from it. Now, why is the discovery of this planet so amazing? Because according to astronomers, it's been forming in a very bizarre way. Or should I say, IS forming, since this gas giant is still in the process. Anyway, the unusual thing is that AB Aurigae B is coming together as a result of a top-down gravitational collapse of giant clouds of gas. But scientists say that a much more common model of planetary formation is when dust and rocks gradually accumulate around some kind of core. This proves the idea that there are numerous ways for planets to form. It can also mean that there probably are very diverse planetary systems in our home Milky Way galaxy. But AB Aurigae B isn't the largest exoplanet ever discovered. In 2005, astronomers spotted a mysterious space body. Later they called it GQ Loopy b. The thing was orbiting a young star at a distance 2.5 times greater than that between the Sun and Pluto. Scientists came to the conclusion that the object was either a planet or a brown dwarf, which is basically a tiny star. If astronomers decide that GQ Loopy b is a planet, it will be the largest ever found, with a radius that is 3.5 times that of Jupiter. The biggest star we know about is called TOI715b. This hypergiant has a radius that is about 1,700 times greater than that of the Sun. If you somehow managed to place TOI715b in the center of the solar system, its edges would stretch far beyond Jupiter's orbit. As for the dust and gas streaming from the star, all this would extend beyond the orbit of Pluto. That's 400 times the Sun-Earth distance. A black hole is a spot in space where the pull of gravity is so strong that even light can't escape it. But why is gravity so powerful there? Because matter is squeezed into a teeny tiny space. Supermassive black holes, which can be many millions of times the mass of the Sun, tend to lurk in the centers of galaxies. The most massive black hole astronomers have discovered so far is TON 618. Its mass is equal to that of 66 billion suns. It was the year 2010 when, with the help of the Fermi telescope, astronomers spotted ginormous something entering the Milky Way. Their discovery looked like massive blobs of matter that could only be observed in particular wavelengths of light. They were also about 25,000 light-years tall. Scientists think that the blobs, called Fermi bubbles, could be produced by our galaxy's central black hole. Space seems to be extremely deserted, but some places are even emptier than the rest, like supervoid and Eridanus. Astronomers noticed this huge region of empty space in 2004. The area stretches 1.8 billion light-years across. It's mysteriously devoid of gas, dust, stars, and even dark matter. A nebula is a massive cloud of gas and dust floating in space. Some nebulae form when a star is nearing the end of its life and throws out loads of gas and dust. Others appear in regions where new stars are forming. The largest nebula we know about is the Tarantula Nebula. In its longest span, it measures over 1,800 light-years. This nebula, also known as 30 Doradus, is located around 170,000 light-years away from Earth. Unlike its namesake, the tarantula isn't dangerous. Quite the opposite. It's a stellar nursery, which means it's a region where tons of young stars are born. Even cooler, it's the most active star-forming area in our entire galactic neighborhood. In 2021, the biggest ever comet we know about entered our solar system. It was 85 miles across, and its icy nucleus was 50 times greater than the nucleus of the previous record breaker. The intruder's mass was a whopping 100,000 times bigger than that of an average comet. In fact, C2014 UN271 Bernardinelli Bernstein was so large that astronomers first classified it as a minor planet. Is it going to crash into Earth? Nah, it won't get closer than 1 billion miles to our beautiful green planet, and it won't happen until 2031. But could there be comets even bigger than that? Who knows? But the thought is terrifying. There are loads of bizarre things in the universe, and hypothetical nuclear pasta is one of them. If it does exist, nuclear pasta is the strongest material in the entire universe. It forms from the leftovers of extinguished stars when this substance gets squeezed into spaghetti-like tangles of material. It can theoretically break, but only if you apply 10 billion times the pressure needed to shatter steel. Pulsars are spherical space objects the size of a large city, but they pack more mass than the entire sun. They radiate 2 narrow beams of lights, sending them in opposite directions. The Black Widow pulsar, just like its spider namesake, is munching on its partner. It's a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes its companion star to dwindle. Haumea is a dwarf planet orbiting in the Kuiper Belt, a donut-shaped ring of objects around the Sun that extends just beyond the orbit of Neptune. The mini-planet has a bizarre elongated shape and 2 moons. The day on this planet lasts just 4 hours, which makes it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile wide ring circling it. What is it? Where did it come from? No one knows. Could be the result of a collision that happened in the distant past. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because of a ring of dust and debris circling it. It makes the star look like a giant eye staring into your soul. The intimidating star is more than twice the mass of the Sun. It's 25 light-years away from Earth, which isn't that far away considering distances in space. Look at this butterfly. Its wingspan is more than 3 light-years, and the structure inside this nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an incredible 450,000 AF. It means it was formed from another gargantuan star more than 5 times the size of the Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly. The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler, NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. Let's be coy, K-O-I, shall we? This wonderful planet is in the constellation Cygnus, and why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet TOI715b orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Our sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than the Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Ideally, we need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely that there will be at least some organisms there. KOI 57115.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees, which is slightly less than ours, 57 degrees. But it most likely feels warmer there, because strong gravity helps it hold onto heat in the atmosphere longer. It's a little too far away though, like 3,000 light years from Earth, which is about 18 quadrillion miles. Yup, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on the Earth. The more heat there is on the planet, the more comfortable it's to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.12 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The resemblance is so striking that scientists believe that we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? What do you think they could look like? Very Earth-like planet, but with stronger gravity. If someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them, and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin, because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near the red dwarf, Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. You'll probably say, but won't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But, of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today it's just a red desert, and there is no life there, at least not as far as we know. But you see how important these tiny details are? This planet is also quite far away from us, 490 light years. It's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62 Zens and Kepler 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62m is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, about 1,200 light years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we've talked about. Scientists believe that both 62e and 62f are sort of water worlds. Warm places mostly, or even completely, covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some. Think Hawaii, and a nightmare for others. Think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What is its composition? Density? One day, maybe we'll be able to answer these questions. And so, that's it for the super Earths. Of course, the original list is much longer, and you can go check it out on the internet. The best thing about all this is that these are the planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are a few of them have at least some form of life. But they're very, very far away, so we have no way to check it right now. Perhaps down the road, we'll find some cool creatures on many of them.
Hey, did you know that recently we've picked up several exciting hints about life beyond Earth? Strange gases in distant atmospheres, important molecules swirling around newborn stars, ideas that cosmic radiation could spark life beneath frozen worlds. Okay, sure, it's not a cryptid message from some galaxy with ET saying hello, but taken together, these clues point to something unexpected. Not only could there be life on other worlds, but it might be a lot more common than we ever thought. But first, let's explain how we learn what's out there in deep space. When scientists say, hey look, we found something hundreds of light years away, that doesn't mean they pointed a telescope and zoomed in on a planet like with a mouse scroll on Google Maps. Most planets are invisible, drowned out by their star's light. Instead, researchers study starlight as it filters through a planet's air. Different gases absorb specific colors, leaving a unique chemical fingerprint. decode the missing colors, and congratulations, you know what's in the air. And that's what the James Webb Space Telescope is built for. The James Webb is incredibly impressive. NASA claims that the telescope is so precise it could detect the heat signature of a bumblebee on the Moon from Earth, if the bee stayed still long enough. That's not even the best part. Unlike regular telescopes that see visible light, JWST sees in infrared. It doesn't usually show us those far-off planets directly. Most of the time, it reads the starlight that filters through their air. Thanks to its giant gold mirror and super-cold instruments, it can pick up faint traces of certain gases from hundreds of light-years away. Maybe it won't show us little green men, but if they're out there, we might learn what they're breathing. Which is what happened recently when researchers looked at K2-18b, a planet that's about 120 light-years away. They picked up signs of a gas called dimethyl sulfide. Never heard of DMS? That's fair. But here on Earth, DMS is made almost entirely by life, specifically tiny ocean creatures like plankton. So, if you're detecting DMS here, you're probably standing near seawater with a high-tech measuring device. The whole DMS discovery sounds huge, but hold on. It's a bit early to celebrate. This doesn't mean there's a bikini bottom on K2. The signal is faint, and scientists are still debating if it's even real. And even if it is real, life isn't the only explanation. Lab experiments in 2024 suggested DMS might also form without biology under certain exoplanet-like conditions. We've even detected it in comets and interstellar clouds, places where no one expects living plankton. Still, the evidence is strong. Additional studies have shown that the odds of this signal being just a random mistake are less than 0.5%. That's solid by scientific standards, a real, okay, let's take this seriously moment. Experts say that the key question is, what kind of atmosphere does K2-18b actually have? If it's deep and heavy, abiotic chemistry could explain DMS just fine. But if it's shallower and has a liquid ocean underneath, then biology might be the best and most exciting explanation we've got. Either way, the outcome is huge. Scientists are either seeing the first signs of extraterrestrial life or discovering a brand new kind of chemistry. But it gets better, because the next theory comes not from examining a planet, but from what's around a protostar called V883 Orionis, in a completely different part of the galaxy, located 1,300 light-years away. Scientists notice something special. The baby star is still forming, wrapped in a swirling cloud of gas and dust. And inside that dusty cloud, astronomers have found 17 complex organic molecules, the kind you find in biology textbooks. We're talking about molecules like glycolaldehyde and glycolanotril, which might sound like names for supervillains made of sugar, but they're actually precursors to stuff found in DNA and RNA. From what we already know, this is quite confusing. For a long time, scientists believed these molecules only formed later, after planets cooled, oceans appeared, and chemistry had time to simmer. Some even suggested they had been brought to Earth aboard comets and asteroids, forming in deep space and surviving the cosmic journey. This concept is called the panspermia theory, and is still debated. Regardless, it's unexpected to see pieces of the life puzzle floating around a half-built star. It's kind of like having flour and baking soda before the fire is even a thing. And it gets better. These molecules weren't destroyed by the radiation blasting out from the newborn star. In fact, some scientists think the radiation might have actually helped create or preserve them. So, what does that mean? It means that basic chemistry for life might not be rare at all. In other words, the recipe for life might be already baked into star systems before planets even appear. The ingredients don't have to be created later. They're already there, just waiting for the right planet to form in the right place at the right time. But what if that's not the case? What if life doesn't even need a star in order to exist? For decades, we believed the Goldilocks zone was the only place where life could happen. The perfect cozy location. If a planet is too close to its star, the oceans boil and you get something like Mercury or Venus. If it's too far, everything freezes, and you have a giant ball of ice. However, the latest study suggests that deep underground, sunlight might not matter at all. A group of scientists ran computer models that suggested life could potentially exist in super dark, frozen places, similar to what's beneath the surface of Mars, on Europa, or rogue planets, all thanks to cosmic radiation. That's right, high-energy particles from deep space are constantly pelting planets and moons at nearly the speed of light. Normally, radiation is the bad guy. It mutates cells, damages DNA, and even fries spacecraft electronics. But in the right conditions, it might have different roles. Earth is protected from cosmic rays because it has a thick and awesome atmosphere. But on planets with thinner atmospheres, like Mars, these rays can reach the surface and possibly below ground. Cosmic rays hitting underground ice can split water into useful chemicals like hydrogen, oxygen, and other reactive stuff that might support microbes, just enough to kickstart life. This led researchers to propose a cool new idea: the radiolytic habitable zone, a region where cosmic radiation is the main energy source driving chemistry underground. Simulations show that Enceladus, one of Saturn's moons, might be the best bet for life supported in this way. This really changes everything, because if life doesn't need warmth, sunlight, or even a star, then our idea of habitable may be way too narrow. Suddenly, there are way more worlds that could have life hidden away. Very primitive forms of life, because without sunlight, there's no photosynthesis, no plants, no food chains like we know them. The energy supply is just too small. So, as far as we know, complex life probably still needs a star. But simple life? Not necessarily. On Earth, some of the oldest and toughest organisms live off chemical energy deep underneath. Surviving without the sun, bacteria in caves, microbes beneath glaciers, and even weird life forms near boiling vents at the bottom of the sea. They might thrive by tapping into the chemistry around them. These are called chemoautotrophs, and they might be exactly the kind of life that's most common in the universe. We'll just have to wait and see. So, to recap, life might be floating in alien atmospheres, hiding in baby star clouds, or stuck deep underground, eating cosmic rays and radioactive things. If all of these theories turn out to be correct, it's not just exciting, it's revolutionary. Life doesn't need ideal conditions. It adapts, it endures, and maybe it's everywhere. Not to mention that there still might be some complex life forms out there. We just can't see them. Or maybe they're staying silent, like the universe is a dark forest. Space is just that huge. By the time the James Webb Space Telescope captures something, it might already be gone. Until ET sends us that message. If we don't want to feel alone in the universe, even a microscopic cell counts.
Hey there, Earthling! If you think you're special because you live on the only habitable planet out there, think again. What makes a planet suitable for life? A whole bunch of factors, like the planet itself, its neighbors, and the star it orbits. A habitable planet is basically one that can sustain life, with things like access to water, energy sources, and nutrients. Earth, for example, is in the sweet spot, known as the habitable zone, where it can have liquid water on its surface. But just being in this zone doesn't automatically mean a planet is habitable. Factors like crazy levels of radiation can make a planet uninhabitable, even if it has the right temperature. So the bottom line is, we need water, something to orbit, and a set of nutrients of chemical origin that can be found in Mendeleev's periodic table of the elements or those funky snacks you buy. Look at this exoplanet called K218b. The term exoplanet doesn't mean that it's exotic. It just states that this planet is located outside the solar system. Most planets need to orbit something, unless we're talking about rogue planets that are basically planet-sized things floating around in space but not orbiting around any star or brown dwarf. Instead of our Sun, K218b orbits a red dwarf called K218. It's not your average star you can see with the unaided eye in the night sky. This one is hard to observe because of its low luminosity. K218b is indeed a planet far, far away. It's located 38 parsecs away from Earth. 1 parsec is somewhere around 19 trillion miles. Hey, you do the math. Hint, lots of zeros. K218b is a sub-Neptune, meaning that it has a smaller radius than Neptune. However, it's much bigger than our humble abode. It's about 2.6 times the radius of Earth. As for the weight, K218b is way chunkier than Earth. It's about 8 times as massive. It takes 33 days for this planet to go around its star, and it gets just about as much starlight as Earth gets from the Sun. This planet has a light intensity of 1.28 times greater than Earth and has an equilibrium temperature of 28 degrees Fahrenheit. Nope, it doesn't mean that K218b feels like New York in January. It only gives us an idea of the theoretical temperature put there. The planetary equilibrium temperature is basically the temperature a planet would have if it was perfectly balanced in terms of radiation. It's when the amount of heat leaving a planet is the same as the amount of heat coming in. Now, the trillions of miles that set us apart aren't a problem for potent telescopes, such as the Kepler Space Telescope that discovered this planet and the James Webb Space Telescope that is studying its atmosphere now. In 2019, scientists announced that they had found water vapor in the atmosphere of exoplanet K218b, which sparked widespread interest toward this outlandish world. 4 years later, the Webb telescope detected carbon dioxide and methane swirling in the air of this guy. Carbon dioxide is basically our best friend here on Earth. Humans need it to breathe properly and keep our blood pH in check. And plants love this stuff too, because it helps them make oxygen through photosynthesis. Obviously, we can't survive without it. Without methane either. However, this little gem got some scientists buzzing with excitement even more due to the discovery of some funky dimethyl sulfide gas molecules in its atmosphere. In 2023, scientists from the University of Cambridge spotted carbon-based molecules like methane and carbon dioxide hanging out on K218b with the help of JWST. This could mean that this exoplanet might feature a hydrogen-rich atmosphere and a watery surface. There's a potential whiff of dimethyl sulfide or simply DMS in the mix. On Earth, this stuff is usually linked to life, since it's normally produced by photoplankton in the oceans. The fact that we're picking up hints of DMS on K218b is like finding a golden ticket in the cosmic chocolate bar. Hey, kinda gives you the willies now, doesn't it? Why is DMS so important, you ask? Well, it's a bit of a superhero on our planet, playing a crucial role in the sulfur cycle and even affecting our climate by helping clouds form. And spotting DMS on other planets could be a sign of life similar to ours. Looks like this planet is a nice spot with its not that rough temperature and all the right nutrients to keep us alive. So, what's your take on its overall look? It probably took the planet a good few million years to come together. While things might heat up deep down underground, it shouldn't make a big difference on the surface. Some experts believe it could be home to a water or molten lava ocean with a hydrogen-rich atmosphere resembling a gas giant like Uranus or Neptune. Now this one doesn't really match our Earth standards, since our atmosphere is mostly made of nitrogen. If there's an ocean, it's likely under a thick layer of ice and rock, which could mess with the planet's climate. Once things get really hot, the line between the ocean and the sky blurs. We're not totally sure if there's a liquid ocean on K218b, and it's tricky to see one from afar. Just looking at the planet's size and weight won't give us the answer. The whole liquid water ocean thing is up in the air. Initially, we thought water in a supercritical state was most likely, but new observations point toward a liquid ocean. Suspicious gases like hydrocarbons and ammonia might be moving from the air into the water if there's an ocean, which could mean no clear line between the sky and the sea. But some experts say a molten rock ocean could be doing the same trick, Others think a gas-rich mini Neptune setup could explain things too. The Hubble Space Telescope did some snooping and found that K218b is rocking an atmosphere filled with hydrogen. They think there might be some water vapor hanging out there too, but it's a bit of a mystery. Apparently, the James Webb Space Telescope got a peek and saw less than 0.1% water vapor, possibly because the planet has a dry stratosphere vibe going on. As for ammonia, it's nearly non-existent in that distant world. Methane and carbon dioxide seem to be dominant in the atmosphere, making up about 1%. But don't expect to see any other carbon oxides crashing the party. Their concentration is just a guess at this point. The atmosphere of K218b is just a small fraction of its total mass, around 6.2%, and has probably got a similar vibe to Uranus and Neptune. Haze-wise, there's not much going on, and water clouds are a bit of a mystery. They're probably icy, although there's a chance for some liquid water clouds too. Now, besides water, the atmosphere could also contain some ammonium chloride, sodium sulfide, potassium chloride, and zinc sulfide clouds, depending on what the planet is into. And it seems like things might get a bit turned up high in the atmosphere, with the temperature inversion causing a stratosphere situation, just your average day in outer space. So far, scientists have come up with several climate models this planet might have. For example, some of them think that there's the same temperature across the whole planet, unless the planet is spinning super fast and the temperature difference between the poles and the equator is minor. But these are all speculations at this point. The amount of radiation K218b gets from his star is similar to what Earth gets. The temperature on the planet might be anywhere from really cold to pretty warm. Whether it can support life depends on its atmosphere and clouds. Scientists think microorganisms from Earth could survive there, even with all the hydrogen. But it's still hard to tell if there's life on K218b, because the gases we usually look for might not work in its atmosphere. Scientists think the James Webb Space Telescope might be able to detect different markers of life on the planet with enough observations.
Look at this fascinating planet. It looks as if it's burning. It must be hotter on its surface than in the middle of Death Valley. The ground is parched, cut by giant cracks. There's not a drop of water in this boiling world. Now, it's the same planet, but it looks like a totally different place. Everything is frozen. The temperatures are so low, there isn't even a tiniest chance that life could survive on this planet. This bizarre world is called HD20794D, and it's located 19.7 light-years away from Earth in the constellation Eridanus. This planet is a super-Earth. This term means that it is larger than Earth but smaller than such ice giants as Neptune. What makes this planet especially interesting is its unusual orbit, which moves it in and out of its star's habitable zone, the region where temperatures might allow liquid water to exist. Now, we haven't seen this unusual planet directly. Astronomers detected it by measuring tiny wobbles in its star using two powerful instruments, espresso and HARPS, located at telescopes in Chile. These instruments measure radial velocity, which is the small movement a star makes as a planet's gravity tugs on it. The larger the wobble, the more massive the planet. Later, astronomers analyzed the data and figured out that the planet in question has a mass around 6 times greater than Earth's. It orbits a star, which is slightly smaller and dimmer than our Sun. What makes this star unique is that it is bright enough to be seen with the unaided eye, unlike many other stars that host exoplanets. You won't be able to see them without a telescope. The star system has been observed for over 20 years. Astronomers have long suspected it had multiple planets. In 2011, scientists discovered 2 other super-Earths orbiting the star every 18.3 and 89.6 days, respectively. For some time, researchers thought they had found a third planet with an orbital period of 40 days. Later, they realized they had made a mistake. But recently, after reanalyzing years of data, astronomers have confirmed that the third planet does exist, and it's our extreme HD20794D. A researcher from the University of Oxford played a key role in identifying the planet. He used a special computer algorithm called Yarara to separate the planet's weak signal from the background noise. It helped him confirm that the planet truly existed and was pretty unique. Unlike the planets in our solar system, which have mostly circular orbits, the newly discovered one follows a highly elliptical, stretched-out orbit. It takes 647 days to complete one trip around its star. That's just 40 days shorter than Mars's orbit around the Sun. At its furthest point, the planet is twice the Earth-Sun distance, which makes it an icy world far outside the habitable zone. At its closest point, it moves inward to 0.75 AU, where it enters the habitable zone, where liquid water might exist. This extreme movement creates truly bizarre seasons. For some part of its orbit, HD20794D is frozen, like an icy wasteland. As it approaches its star, temperatures rise and ice likely melts, forming temporary oceans. The planet then experiences a short, scorching summer. It is so hot that the water on its surface might evaporate into the atmosphere. Shortly after, the planet moves away again. It triggers a gloomy fall with rains, followed by a deep freeze in winter. In other words, the planet switches between extreme cold and intense heat, which makes it a very unpredictable place for life. If any life forms exist there, they certainly need to adapt to dramatic changes in temperature and environment. Why does the planet follow such a mind-boggling orbit? It might be a leftover effect from events billions of years ago, when the planetary system was still forming. At some point, another large planet may have disturbed the orbit of our extraordinary friend. Another possible explanation is that a giant planet once existed in the system, and its gravity pushed HD20794D into an elongated path. Later, this giant planet may have been ejected from the system, leaving the smaller planet in its current orbit. This theory makes sense because the two other planets in the system, B and C, have more normal circular orbits. The discovery of this planet is so exciting because it challenges what we know about habitable planets. Most planets in the habitable zone stay there permanently, but HD20794D only passes through it. Scientists want to know if such a planet could still support life, even briefly. So future telescopes will study the atmosphere of this planet, looking for signs of water, gases, or even life. Another super-Earth that might have the right conditions for life orbits a star 137 light-years away. In space terms, this is considered relatively close. A light-year is around 6 trillion miles. The planet is called TOI715b, and it's about 1.5 times the size of Earth. Unlike HD20794D, it's permanently located in the habitable zone. Look, that's what astronomers think the planet might look like. TOI715b orbits its star very quickly, completing a full orbit in just 19 days. But even though it's close to its star, it may not be extremely hot, all because its star is a red dwarf. That's a type of star that is smaller and cooler than our Sun. This means TOI715b could have a milder temperature compared to other exoplanets that orbit closer to hotter stars. NASA discovered the planet using the Transiting Exoplanet Survey satellite. This space telescope finds planets by watching for small dips in a star's brightness, which happen when a planet passes in front of it. Since red dwarfs are smaller and dimmer than the Sun, planets passing in front of them are easier to detect. Astronomers are planning to study the planet further using the James Webb Space Telescope. This powerful telescope, located 1 million miles away from Earth, can analyze the atmospheres of distant planets. If TOI715b has an atmosphere, JWST could help scientists determine what gases are present in it and whether such conditions could support liquid water or even life. One more promising world for our search for extraterrestrial life is an extremely dense super-Earth in the K2360 system. An international team of researchers from Japan and Europe has discovered this remarkable multi-planet system orbiting a Sun-like star located 750 light-years away. This system has 2 planets, including one of the densest rocky planets ever found. The K2360b is a rocky super-Earth, about 1.6 times the size of Earth, but with a mass 7.7 times greater. This makes it as dense as lead. The planet orbits its star incredibly fast, completing one full orbit in just 21 hours. It's the densest known ultra-short period planet with well-measured properties. As for its sibling, this is a much larger outer planet with at least 15 Earth masses. It takes 9.8 days to orbit its star. Sadly, since it does not pass in front of its star from our viewpoint, scientists cannot determine its exact size. The unusually dense planet might be the core of a much larger planet. Over time, intense radiation from its parent star may have blown away its outer layers, leaving behind only its dense, rocky core. So, in fact, this planet could show us what might happen to some planets that are too close to their stars. Astronomers think that the planet may have moved inward over time due to interactions with its larger companion planet. One possibility is high eccentricity migration, where a planet's orbit becomes highly stretched out due to gravitational interactions before gradually becoming more circular near the star. Another theory is that the planet's spin and axial tilt can cause its orbit to become more circular. Such planets are rare, and finding one with a massive outer companion can help scientists refine their theories about how planets form and evolve in extreme environments. With its help, we might also understand how rocky planets evolve and what happens to planets that get too close to their stars.
On our good old planet Earth, water is literally everywhere. Not only in the oceans and seas, but also in the atmosphere, in the ground, and even in ourselves. It covers as much as 71% of the surface of our planet. Looks like our planet should have been called water and not Earth. But what would happen if water and land were distributed equally? What if half of the planet became land and the other half was water? Let's find out. First of all, let's discuss what we mean by equally. Despite all the things mentioned earlier, there's actually not so much water on our planet. Yeah, if you collected it all in one giant drop, it'd be slightly larger than the USA in size, and all this amount of water would be only 0.02% of the total mass of Earth. So it turns out that all these horrifying unexplored ocean depths are basically nothing. And now, just imagine if we changed the composition of our planet by leveling the volume of water and land. What would happen then? Then we'd get a very creepy ocean planet. This planet would look like one boundless ocean. It's very unlikely that you'd find even a couple of small islands on it. And if you did find them, they'd probably be the tops of huge underwater mountains. This world would be practically uninhabitable. If you were on its surface, you wouldn't be able to see the sun or anything else in the sky. You wouldn't know what time of day it is or where exactly you are, all because of the incredibly thick fog and clouds. This kind of weather would be permanent on such a planet. Moreover, you wouldn't even understand where the fog ends and the water begins. All because the humidity would be that high. But could there still be life? Maybe inside the ocean itself. Unfortunately, this is also quite unlikely. You see, to get to the bottom of this ocean, you'd have to swim vertically down not for several hours, but for several days. And even after such a journey, you wouldn't see the bottom yet. The ocean wouldn't be bottomless, of course, but the seabed would consist mainly of very hard, impenetrable ice, but not the kind of ice we're used to. This ice would be exotic. There are different types of it, called Ice V, Ice VI, and so on. Usually, these types of ice aren't as cold as regular ice and may not melt even at very high temperatures. And there would be almost no algae or anything like that, so fish would simply have nothing to eat. That's why if life appeared on such a planet, it would be a miracle. This life would have to withstand a pressure of more than 20,000 Earth atmospheres. Even the most horrifying monsters from the Mariana Trench would be nothing in comparison to the creatures you'd find on this ocean planet. But could we, humans, live there? Well, theoretically, yes. But it would be extremely hard. We could create something like giant underwater stations, but we would still have thousands of problems. Where to get food and other resources, how to repair stuff, and so on. So it would be far from the best option. Okay, now we know that an ocean planet doesn't sound too endearing. What about another option? What would happen if the surface of Earth was 50% water and 50% land? For this to happen, we'd need to reduce the current amount of water from 71% to some 50%. In this case, the sea level would drop by about 2 miles, and about a quarter of our planet would become dry land. Although it doesn't sound like much, the consequences would be disastrous. Right now, there are 5 interconnected oceans on Earth: Atlantic, Indian, Pacific, Southern, and Arctic. But if we lowered the sea level, all these oceans would simply disappear. They'd turn into separate closed reservoirs and seas. On the contrary, all the continents would merge into one giant landmass, almost as if we swapped the land and water. And at first, it would seem pretty cool. Now you'd be able to literally walk around the world. However, the amount of land you'd have to travel would also increase. Every continent on the planet would grow in size. All this new territory would be approximately equal to the current area of Asia, Europe, Africa, and North America combined. Well, that would be a huge mass of unused space. But what would we find on these new territories? Most of them would be pretty flat, but in places where there used to be deep oceans, you would see vast corridors and steep crevices. Here's another cool thing. Most of the sunken cities would return to the surface. And no, unfortunately, we wouldn't find Atlantis among them, but there would still be a lot of other cool places. For example, the ancient Roman city of Baiae, which, according to legends, was basically a paradise on Earth with all its luxurious villas and gardens. Or Heraklion, the city that went under the sea thousands of years ago and was considered a myth for a long time. So yeah, we could organize tours to these ancient places. But of course, not everything would be fun and games in such a world. Due to such a severe loss of water, ocean currents would be disrupted, and this would lead to very serious climate problems. The ocean absorbs the heat radiated by the sun. Thanks to the currents, this heat is distributed all over Earth, which creates a stable and pleasant climate. But if these currents were disrupted, then the temperatures on Earth would become more extreme. It would get much hotter near the equator and even colder around the North and South poles. So yeah, unfortunately, the Antarctic ice wouldn't save us. It would be quite the opposite. The regions around the North and South poles would completely dry out, basically turning into dry, cold deserts. In addition to heat, water also absorbs carbon dioxide from the air. And since the oceans wouldn't be able to absorb it, this gas would begin to accumulate in the atmosphere. This poisonous excess would cover the entire planet. The average temperatures would increase, and the whole planet would start to dry out slowly. Massive forest fires would break out, and so on. Sound familiar? To make matters worse, there would be nothing to extinguish these fires. Because, you know, rains can't form from nothing. So yeah, the precipitation levels would fall, and this would lead to dangerous droughts. We'd get a bunch of new deserts on all the continents. Despite getting all those new territories, it's unlikely that we could somehow build new cities and towns there. Many of these territories would be uninhabitable. Not only because many forests and plants would disappear, but also because most animals would migrate to more pleasant places. As a result, we would have great difficulty finding any food at all. So all life on our planet, plants, animals, and people, would have to adapt to new living conditions. They would have to evolve quickly and get used to the constant shortage of water. Animals, for example, could shrink in size because of this. Many of them, due to the lack of grass and moisture, would switch to a strictly carnivorous diet. And of course, we would have to say goodbye to the huge abundance of marine life. Many fish would disappear forever. Humans most likely would make a big evolutionary leap backward. Not only because we would lose a large number of resources and move to new territories, but also because we would also lose access to one of the most important sources of energy in the world, hydroelectric power plants. Without electricity, many factories would stop working. To say that this would cause a large-scale crisis for us all is sadly obvious. So, our current ratio of water and land is the best possible option. If there was too little or too much water, the consequences would be awful. That's why we need to protect the current conditions with all our might.
So, astronomers have just announced that they might have found signs of possible life on a planet outside our solar system. Wow! This distant world is called K2-18b, and it sits about 124 light-years away in the Leo constellation. So, what life are we talking about? Little green men? Octopus-like tentacled creatures? Well, not exactly. First things first, let's define what life is. It's what distinguishes animals and plants from inorganic matter, like the ability to grow, reproduce, and change. Now, what do we need to support life? If what comes to your mind is water, bingo! Scientists have the feeling that K2-18b might be covered in oceans, and if it's so, it can support tiny forms of life like microbes. A team of researchers from the UK and the US used the James Webb Space Telescope to look at the planet's atmosphere. They found hints of two very special chemicals. On Earth, only living things can produce those, and the living things I'm talking about are mostly tiny ocean plants called phytoplankton. So, basically, this planet might indeed host life in the form of algae. Now, of course, scientists still need more proof before getting too excited. We should keep in mind that it's possible that those chemicals were made by something we don't understand yet, not necessarily by living things. But still. K2-18b is a big boy. It's more than 8 times heavier than Earth and about 2.5 times larger. So what makes it even more interesting is that it's located in the Goldilocks zone around its star. That means it's not too hot and not too cold there, just right for the existence of liquid water, which is highly important for life, as we know it. Astronomers study faraway planets like this by watching how their light changes when they pass in front of their star. This allows us to figure out what kinds of gases are in the planet's atmosphere. Back in 2013, the James Webb Space Telescope found methane and carbon dioxide in the atmosphere of the planet. These are carbon-based molecules, and it was the first time they were found on a planet in the habitable zone. Scientists also saw a weak signal of a chemical called DMS, which is mostly made by tiny ocean life here on Earth. So, the researchers pointed the telescope at the planet again a year later using a different tool that could pick up more light details. This time, they found much stronger signs of DMS and some related chemicals. But the problem is the signals aren't strong enough yet. They haven't reached something called the 5 sigma level, a parameter scientists use to confirm discoveries. Plus, even if the DMS really is there, it doesn't automatically equal the existence of life. Scientists once found DMS on a comet, which means that it can be produced without some kind of life taking part in the process. And still, the amount of DMS on K2-18b looks way higher than anything seen on Earth. That's why some astronomers are sure it's coming from something living. K2-18b has been a top pick for what scientists call a Haitian planet. This term means a big, watery world with thick hydrogen atmosphere. It's not the kind of place where extraterrestrial civilizations like in movies would live. But it could be home to tiny life forms, like the microbes that once lived in Earth's oceans billions of years ago. Once again, not everyone agrees on how friendly K2-18b really is for life. Some scientists think planets like this might actually be too close to their stars to hold on to liquid water. K2-18b orbits its star every 33 days, which is pretty fast, and could mean it's too hot. That's why some experts claim that even if the planet has any water at all, it might be boiling. Or maybe it's not water, but oceans of lava. But most scientists agree on one thing: we should wait and see. With just 16 to 24 more hours of telescope time, astronomers could confirm what they've seen. This could happen in the next few years, and even if it turns out K218b isn't the world we're looking for, we're still getting close. With powerful telescopes like James Webb and more coming in the future, we might be able to answer whether we're alone in the universe or not. At the same time, some places in our own solar system, like Mars, Venus, or Saturn's moon Enceladus, might actually have a better shot at hosting life. Or we could keep exploring other promising worlds, like Proxima Centauri b, which is the closest exoplanet we know about. It's just 4.25 light-years away from us and orbits a small star called Proxima Centauri, right in the habitable zone. This planet is a bit bigger than Earth, which makes it a super-Earth. That's what we call exoplanets larger than ours, but much smaller than gas giants like Neptune or Jupiter. Proxima Centauri b is a fast-moving world. It needs a mere 11 days to go all the way around its star. Scientists think Proxima Centauri b might have a rocky surface, and that's a good sign for possible life. On the other hand, its star blasts it with a lot of ultraviolet radiation. It might have already destroyed the planet's atmosphere, if there was any to begin with. So there's a big question mark when it comes to this world's habitability. Then we've got TRAPPIST-1e, another promising Earth-like planet. It's one of 7 rocky planets orbiting a small, cool star called TRAPPIST-1, about 39 light-years away. Discovered in 2017, it might be one of the most promising places to look for life beyond Earth. This planet is actually a bit smaller than Earth, with a mass around 1/2 that of our planet. It completes an orbit around its star in just 6 days, which is super fast compared to Earth's 365 days. The planet's size and density suggests it has a rocky surface, and that's another key factor when we talk about habitability. Even though TRAPPIST-1e is very close to its star, the star is quite dim and cool, so the planet might still have a stable Earth-like climate. Some scientists even think it could have more water than Earth. Let's move on to Kepler-186f, located about 500 light-years away. It was the first Earth-sized planet found in a habitable zone of another star. It orbits a red dwarf, which burns cooler and lives much longer than our Sun. This means Kepler-186f could have stable conditions for billions of years, giving life plenty of time to possibly form and evolve. The planet gets only about 1/3 of the sunlight Earth receives, so it would likely be cooler but still warm enough to keep water from freezing. It also seems to be a rocky planet just like Earth, which boosts its chance of hosting life. Now, how about visiting LHS 1140b, about 40 light-years away? This planet has about 5.5 times the mass of Earth. Scientists think it's rocky and possibly has a thick atmosphere, which is a big deal. An atmosphere like that can trap heat, keep temperature stable, and protect water from escaping into space. This world orbits a quiet red dwarf star, so it's not constantly blasted by harmful flares like some other exoplanets are. Some studies even suggest LHS 1140b could be an ocean world with lots of water. So it's one of the more exciting planets we've found in our neighborhood. And finally, we have Gliese 12b. Astronomers call it ExoVenus. It sits 40 light-years away from Earth. This world is about the size of Venus and orbits a cool red dwarf star. It needs just under 13 days to complete one orbit. The temperature on the planet is around 107 degrees, which is quite warm, but still okay for life. The thing that makes Gliese 12b so interesting is that it could help us understand how Earth-sized planets around cool stars hold on to their atmospheres. That's important because an atmosphere is crucial for things like liquid water and protecting life from harmful radiation. According to some researchers, Gliese 12b is one of the best chances we have to figure out whether planets like this can stay habitable.